Hi, let's take a look at the Cohen's kappa for reliability. Keen and Prividera used Cohen's kappa measurement to formulate agreement between coders. However, as stated on page 293, they use SPSS to calculate their findings. Let's take a quick look at how this reliability measurement actually works. PR times A simply relates to the observed agreement among coders. PR times E is the probability of chance agreement. Of course, this is strictly hypothetical. K equals 1 represents complete agreement, and K less than or equal to 0 represents no agreement. Example. Let's say two of ECU's communication GAs are coding two different magazines on culture for Dr. Sherman. Some of the units of analysis require a yes-no response, just like in Keen and Prividera's coding scheme located on page 292. Let's refer to the GAs as coder 1 and 2. Okay, now that we've gotten that out of the way, note that there are 20 ads that were approved by both coders 1 and coder 2. I have highlighted them in purple. And 15 ads that were rejected by both coders in gold. Therefore, the observed percentage agreement is PR times A equals 20 plus 15 divided by 50 equals 0.7. This seems painless so far, right? Now let's take a look at how this actually looks. Okay, let's go back to the 20 ads. Both were approved by coder 1 and 2, and they represent 20. Coder 1, 20, coder 2, 20. 15 ads that rejected by both coders in gold. Coder 1, 10, and coder 2, 5, for a total of 15. Let's move on. Now, let's calculate PR times E, the probability of random agreement. We know that coder 1 said yes to 25 ads and no to 25 ads. Thus, coder 1 said yes 50% of the time. On the other hand, coder 2 said yes to 30 ads and no to 20 ads. Thus, coder 2 said yes 60% of the time. Let's take a look at that. Okay, coder 1. 25. Yes. Coder 1. 25. No. Coder 2. 30. 20 plus 10. And no. 20. 5 plus 15. Okay. Seems fair enough. Let's move on. As a result, the probability that both of them would say yes by chance is 0.5 times 0.6 equals 0.3. And the probability that both of them would say no is 0.50 times 0.50 equals 0.020. Let's say that again. As a result, the probability that both of them would say yes by chance is 0.50 times 0.60 equals 0.30, and the probability that both of them would say no is 0.50 times 0.40 equals 0.20. Therefore, the overall probability of random agreement is PR times E equals 0.3 plus 0.2 equals 0.5. As a result, we shall apply our trusty formula for Cohen's kappa. And this is the result. The foundation for this example was inspired by Sir Francis Galton, 1892, one of the first researchers to use the Cohen's kappa. Galton is believed to be a half-cousin to Charles Darwin. This tutorial was brought to you by the Lindo Communication Group. Thank you.